Okay, hello everyone. So we go back and want to look at mathematics. And remember, we've been looking at sets. So in the past few lectures, we've been looking at sets of numbers. As we are aware, we've looked at numbers. Okay, we looked at natural numbers. We also looked at what? Whole numbers. Okay, we looked at whole numbers. Then from there, we looked at what are called integers. Okay. Now, this we basically just defined them and tried to list a few of them. But where there was much story was on rational numbers. Rational numbers. Then after that, we looked at irrational numbers. Irrational numbers. Okay. So this is where much of our story started from. And after that, ideally, here I'm going to leave a little space of what we're going to do today. But we're going to continue with sets of numbers where we have also what are called real numbers. Okay, we have real numbers. And then after that, we have lastly, we have what are called complex numbers. Okay, complex numbers. So under sets of numbers, remained with two sets of numbers, that is the real numbers and the what? And the complex numbers. Okay, so now for today, I've left that space. Okay, I've left that space for today. We're going to look at operation on sets. Okay, want to look at operation on sets. Now, under operation on sets, this is going what something that is going to help us even to look at real numbers very well and complex numbers, especially numbers. Okay, that we have for today. That is the outline that we after we do what we're going to do today. Possibly, if we're going to finish it, then next time we're going to have mathematics. We're going to look at numbers. And now, let's back to today's topic, the lesson. So, operation on sets. I also look at a few laws. Okay, operation on sets. Okay, now operation on sets. Let's say let A, B, and C. Okay, let A, B, and C be any any sets. Okay, and okay, so let's end it there. Then we say then one called the universal set. Okay, so the universal set is a set that is containing all elements and sets under discussion. Okay, so this is a set containing all elements and sets under discussion. Okay, so if of elements that we have and we have then a set that is going to contain all of them is what is called what? The universal set. Female students and male students, right? And then, so we can say that in that class we have a set of females and we also have a set of males. Okay, so I was saying that there is that particular that is contained all sets and elements under what? Discussion. Okay, now the other thing that we want to talk about is what is called the what? Subset. Okay, all right. So we are saying that A subset is a set that is containing elements, okay? If all elements in one set, let's say set A, are belonging to another set, let's say set B, then it means that A is a subset of what? Set B, okay? If every element in set A is also belonging to set B, then A is a subset of what? Of B, okay? So we say that a set is a set that contains, or rather whose elements are all elements of another set. Okay, so I say, for example, if all elements of A are elements of B, then A is a subset of what? B. Okay, and this is written as, how do we denote that? Then written as A subset B. Okay, so it means that all elements in set A are elements of what? Set B. That's what it means. All right. Is there any problem so far? I'm sure these things are things that you did in your secondary school, and they are not new to you. Of course, there are a few things that are going to seem quite new later on as we continue with the lesson. Okay. Then let's look at what are called equal sets. Equal sets. So we say that if two sets A and B contain the exact elements, then they are said to be equal. Okay, they are said to be what? To be equal. Okay, that is, A is equal to what? B. Now, the other way of saying this, all right, the other way of saying that statement is by saying, if two sets are subsets of each other, all right, or rather we're saying that A is equal to B if and only if, okay, A is a subset of B and B is a subset of what? A. In other words, two sets are equal if they are subsets of each other, okay? A and B are subsets of what? Each other, okay? A and B are subsets of what? Each other. That's what it means. Every element in set A is found in B, and every element in set B is also found in set A. Then that means that the two sets are what? Subsets of each other. Okay? The two sets are subsets of each other. Is that okay? Is there anyone with a question on that? So two sets are equal to each other if and only if they are subsets of each other. A is a subset of B and B is a subset of what? A. Okay. Any problem? Any problem from anyone? Um, Kaunda, any problem? Nancy, any problem? You can always unmute yourself and talk to me. Enoch, is there any problem? So if you're sending a text, I'm not there to read the text, okay? So just unmute yourself and speak, okay? All right. So maybe just something of note, especially to those that who follow these lessons on YouTube. So these lectures are given online on an online platform. So we are interacting with students that have joined through the online platform. Okay. All right. So let's continue and look at something else. So we've looked at the universal set, the subsets, and the equal sets. Now let's look at what is called the complement. Or rather, let's first look at what is called a difference of two sets. Or let's start with the complement. Okay, that is number 3. Number 4, complement of a set. Okay. Now here there's supposed to be an E, not I. Now to complement, okay, to complement means to finish, okay, or to how do I put it? To make something complete, okay. To complement means to make something complete. All right. So if, for example, you did not have a hand, okay, your hand was chopped off, and then it is put back, it means that you've been made complete, and uh, that hand is now what is called the complement because it was not there. So that thing that should be added to you for you to be complete is what is called your complement. Okay, for example, in marriage situations or circumstances, you find that one partner will call the other as their complement. Okay, if I have a wife, then I'll call my wife as my complement because somehow together we are forming some sort of a complete team. Okay, so now that's what it means. When we say a complement of a set, is it means that something, those elements that should be added to another set of elements for it to be complete. Okay, for it to be complete, or rather to make the universal set. So a complement of a set is those elements that are not part of a given set, but within the universal set. Remember we said that the universal set is a set that is containing all elements and what? Elements and sets that are under discussion at that particular moment. So if we say complement of a set, it means that the elements that are not part of that given set, the set you're talking about, but they are within the entire universal set. That's what the complement means. Okay. So you say that the complement of a set is the set of elements that are not part as a superscript. Okay. Although most of the times what is preferred is this one. Okay, we prefer you using an apostrophe uh, to denote the complement. Okay, is defined as what? We say A is a set of elements. Okay, is a set of elements X such that X is not a member of A. All right, that's what it means. Okay, sorry for that. X is not a member of A. So any element that is not part of set A is going to belong to the complement. Okay, is going to be part of the complement set. As long as it is not part of set A, then it is part of what? The complement. For example, if the universal set is, let's say 1, 2, 3, 4, 5, 6. Okay, so let's say we have that. Then the set A, is let's say 2, 4, 6. Okay, so let's say that is the set A. Then set A complement is going to be, it's going to include all those elements that are not in A, but they are within the what? The universal set. Now, which elements are those? So we have 1, 3, and 5. Okay, so those elements are not part of set A, but they are within the universal set. So we have 1, 3, and 5. Okay, so those are the elements that are belonging to a complement. Is there any problem so far? Is there any problem? If you have a question, please, you can unmute yourself, you ask the question, and then mute yourself. Any question? Okay, I guess I should proceed. All right, let's look at what is called the difference of two sets. This is number what? Number 5, I guess. The difference of two sets.